Now, permutation, a very small concept. It actually generates from both NCR combinations and factorial. See, you're represented by NPR. Same way you use combination, but to get P, you press Shift plus the multiplication sign, if I'm not wrong. Yep, but the multiplication sign. You press that and you will get the P for NPR, right? And simply, if you want 5 PR, you just write 5P and then 3, and it will give you the answer. That's how you put it into the calculator. Moving on. Now, what is NPR and how is it linked with combination and factorial? Very simple. What NPR does is it selects first. It selects your requirement. You know what N is, you know what R is, you know what C is. It selects at the different combinations. And then from the combinations you have selected, it rearranges them. See, out of the 8, I might have selected 5, and those 5 will be rearranged by 5 factorial. So if I have 8 people, I select 5 for my 5 positions, and then I rearrange them all. They can move around. So it's essentially 8C5 into 5 factorial. For ease, it can be written as 8P5. Same thing. But I would advise you do it the longer way because it's much easier to handle two letters instead of having A, R, C, and P. Just stick with combination or factorial. Now you know the concept. Now let me tell you just one more thing I need to explain before we move on to some questions. Another thing here is that I told you in combination you have to fix things. You cannot just remove the repetitions. You have to account for them by making different cases. May that be 5 2. In your questions I showed you questions where you have to do that and you have the skill. But here your life's way easier. Just like factorial, the keyword, oops, the hell, uh, the keyword you have is arrangements. You see the word arrangements and the positions the amount of people or amount of things you have and the positions you have available are not equal. For example, I have 8 people, 5 places. I do not have 8 people. I do not. It's not like factorial. I have 8 people and 8 positions. That would point towards factorial. Here I have 8 people and 5 positions. So I will use permutations, NPR, right? But the keyword will remain the same, which is arrangements. So that's something to keep in mind. And I was talking about repetitions. You can remove repetitions very simply. For example, if you have A, B, right? And I have three, I want two teams. So you know that will be double A. Then that will be double A again. But see, it will think this way. 3C2 does not know about repetitions, right? And it will be AB. Those are the three repetitions, the three combinations that will be selected. But now I want to rearrange them into 2 factorial. What that means is that these same things will be moved around. Double A again. These two A's will move around to give you the same thing. And then AB will turn into BA because it just moved around, switched positions, right? But I know that A repeats 2 times. So just like in factorial, I can simply just divide this by 2 factorial. The amount of something that repeats, I just put that in the denominator and factorial. And that will just cancel this out and it will give you 3 ways. And how is that 3 ways? See, 1, 2, 3. These all are the same as this. So 1, 2, 3. These are 3 different ways. And that's your answer. You can do it manually and you can either do it through this machine, permutations. And another simple example is A, B, C, how that gives you 3C2 into 2 factorial. There are no repetitions, nothing to divide, just this will give you 6 ways. And how does that work? 3C2 will give you AB, AC, and BC. Those are the 3 different selections. But moving them around will give you 6. Each of them will be moved around. So that will give you BA, that will give you CA, and that will give you CB. So that's how it adds up to 6 ways, manually and the machine. Now to the questions. This is a permutation question, and let me tell you some ways to identify it yourself without the word arrangement in this question. It will be mentioned, don't worry. You can already see a 4-digit number is to be formed out of these digits. So you already know the digits are more, the objects I have are more. I have 9 digits, right? They're more. And I only have to select 4 digits out of these. So and a number needs to be formed. That means what that means is let's do the first part. It says in how many ways can it be done if there is no restriction. 4 digit number banana hai. So 1 2 3 4, 4 digits. And now out of those 1 2 3 4 or 9, out of these 9 digits, I can say out of the 9, 4 will be selected and be placed here, right? That could be 1 2 3 4, that could be 5 6 7 8, anything. But the, in how many ways can it be done? See, they have no restriction on this. There's absolutely no limitation. So what you can do is those numbers will take these places. They can move about these places. The 4 numbers that have been selected can move about the same places to give a new number each time. And that will be your actual answer. This can also be written as, let me make that cleaner, 9p4. But again, I recommend this. And that will be your answer. As simple as that is. Now, another way to identify is a number question. But अगर number question होगा तो you already know that it's either a factorial question or either a permutation question. And think this way, that the selected objects can move about if they are giving a different arrangement. You already know it's a permutation question, right? Because see, they've not used the word select, they are not using the word choose. So you can already know that you're not supposed to just give a selection of how many selections of different combinations. You're supposed to give all the ways of a different number being formed, and that would be choosing the numbers and then rearranging them. That is what you need to identify. Moving on to part B. Part B is even simpler. The number is greater than 4,000. Okay, so let's first think of the number 1, 2, 3, 4. Okay, 4. 4-digit number. Now, the first digit will determine the how big or small a number is, right? So they have asked me to make the number greater than 4,000. Okay, so let me see what I have. I have the letters, the numbers I have greater than 4 are 5 6 7 8 9, all those that are greater than 4. Let me place them as the first digit, because those will now make my choices. So I will, whatever, I'm limiting this first position to only these numbers, which are 5 6 7 8 9. Is that it? Yep. And 4 itself. Now why 4 itself? Because see, it has to be greater than 4,000. The rest, now if for example 4 has been chosen on the first as the first digit, the rest of these numbers and the rest of the remaining numbers will occupy these three positions, and they will move about these positions. Now think of it yourself. If 4 is here and the rest of the numbers are non-zero numbers, it will always give me a number greater than 4,000. So I will put, so all the letters, all the digits I have that are greater than equal to 4, or my criteria, this was 3,000, I would have chosen all numbers that are greater than equal to 3 as the first digit. So those are some tips and tricks. Anyways, let me remove this. Now, think of it this way. See, if it was factorial, I remember doing a question like this. If it was factorial, I would have had to make cases, right? Because I've already told you, if it is something related to factorial, you will have to think of each number individually when the same position requires multiple numbers to take that position, right? But in permutation, you can limit that position. Now how? Now I've already thought of कि भाई इस position पे यही numbers आ सकते हैं. Now think out of this box. How many numbers are in this box of the first position? 1, 2, 3, 4, 5, 6. Out of the 6, only one of these will take this position. That's it. They have been, that one digit has been selected out of these and put here. Now out of the 9, one has been chosen, placed as the first digit. How many remain? 8 remain, right? Out of those 8, 3 positions remain. 3 last positions remain. So any three can be selected. They can come here and move about their own position to give a new number each time. So 8c3 into 3 factorial. And that is your answer. Satisfies your condition. A number will, the first digit has the limitation of always giving a number that is greater than 4,000. And the rest of the positions will take a number, take a digit, place it here and move it about to give a new number each time. Moving on. I hope that's clear. And memorize this pattern, right? Okay, limitation set karo, and then think about the rest of the positions. Now, how do you know if a number is even? Now, how many ways can it be done if the number is even? अब पता कैसे चलता है कि number even है? That is the question. Well, to find out if a number is even or odd, the last digit of a number gives its nature to the whole number. For example, if a number is 56, I will think about this digit, right? If this digit is even, the whole number 56 is even. 564. If this digit is even, the whole number is even, right? So now the limitation has moved from the first digit to the last one. So now let's think about the last position. Okay, Okay, 1, 2, 3, 4. Make this a big dash. How many even digits do I have? 2, 4, 6, 8. That's all. Make this into a box. Now, first, always deal with the box first, right? Out of these four, only let's make that neater. Out of these four, only one will occupy this last position. The rest of them will be free to occupy these positions. So, out of the 8 remaining letters, three can occupy this position and move about. That's it. Easy does it, right? Same thing here. Now do this one yourself. Actually, race me. Well, let's go. 1, 2, 3, 4. All the odd numbers I have, which are 1, 3, 5, 7. Boop, boop, boop. Box them up. Out of these 4, 5, 7, 9 as well. My bad. Almost missed one. Out of the 1, 2, 3, 4, 5. Out of the 5, one can take this position. Then, for the rest of the positions, I have 8 numbers remaining. 3 can take these positions. Move about to give a new number each time, and that is your answer. I hope you won this race. Moving on. Final and most important case of permutations. By the way, just to to give you a little clarity, that permutations has become a very rare question. Now you will mostly see this in, I guess, 2015 onwards. Recently, they've given a higher focus and priority to combinations and factorial, but you will see a smaller incorporation of permutation, and that concept is definitely built through these questions, which you are doing with me right now. So focus. And this one is really important. A very rare question, but very important question. It will perfect your concept. See, this is a double condition. The number has to be greater than 3000 and even. So now I have to think about two limitations. The first letter has a limit that all the digits that will occupy the first position will have to be greater than equal to 3. That's one. 2, 3, no limitations here. Last digit also has a limitation that it has to be even. So the whole number can be even. So I have first, let's put all the numbers here: 3, 4, 5, 6, 7, 8, 9. All these numbers, if placed here, will give me a digit, or all these digits that can occupy this first position. That will allow me to give a whole number which will always be greater than 3000. ये बात समझ आ गई सबको? अब आते हैं last position पे. Now let's not worry about a letter repeating at the moment. Let's first just make a mother case of so we can overlook it, right? So for a number to be even, 2, 4, 6, 8, if these digits are present here, the number will be even. Now, if you haven't noticed the problem, please improve your observation skills. Let's think about this. See, what you're witnessing here is a problem, a dispute between the two limitations, which is, कि bhai, if a 4 is placed here, it cannot be placed here. If a 6 is placed here, it cannot be placed here. Sir, how do we deal with this? How do we know if a 4 will be here and it won't mess with this criteria of being chosen at the last digit as well? That is a problem. So how do we fix this? Easy process. Understand this method I'm about to tell you, and slowly we'll clear the concept up as well, right? So first step you're going to do is simple. You're going to make two cases. First, mark your disputed letters, digits. कंफ्यूजन रहती है मुझे letters और numbers के बीच, माजरत ख्वाह हूँ मैं. 4, 5, 6, 8, 4, 6, 8. These three are the disputed letters, right? So first, mess with your first box only. See, that is the limitation I'm setting to on you. Mess with the first box only. For first digit, first क्या बोलते हैं, फर्स्ट पोजीशन वाली बॉक्स के साथ आपने मैस करना है, बिकॉज उसमें ऑप्शन आते हैं. अभी समझो. Now, first case you're gonna make, is gonna be without the disputed letters. कि भाई disputed are only occupying the last position. So undisputed constant 3, 5, 7, 9. Undisputed letters as the first position, right? Let me make that a line there. So 1, 2, और last position जो है, leave that box as is. 2, 4, 6, 8. फर्स्ट केस में पहली पोजीशन में वो वाले डिस्प्यूटेड लेटर्स को बोला भाई कि the disputed letters will only occupy the last position, right? And we will make another case, so those letters, those digits can occupy the first position as well. But for this case, forget about them taking the first position, first letter. Sorry, and only think about them taking the last digit's position. So let's think about this easy. Out of these four, one of them can take this position. Out of these four, one of them can take this 4, okay, they can take this position. And how many? Out of the 9, 2 have been placed, 7 remain. So out of the 7, 2 can occupy these positions, and they can move about these positions to give a new number each time. Easy, easy thought process. Now for the second case, that is the important one. Second case. Okay, let's change to green. The second case you're gonna make, let me write that, is gonna utilize your disputed letters, your disputed digits. They mean the same thing to me, as your first digit, which were 468. So now you're gonna worry about the disputed letters taking the first position, 1 2, but you will still not mess with the last box. अब बड़ी अजीब सी बात कर रहा हूँ, बट नाउ समझने वाले समझेंगे, समझने वाली बात है और मजा आएगा. प्लीज फोकस. See, why do I not remove these letters from here? Because अगर यहाँ 4 इस्तेमाल हो गया, if 4 is used as the first digit or as the first digit, the rest of them, these two are still free to be used there, right? So now think of it this way. Bear with me. First, play out of these three, one of them can take this position. बाकी digits तो पहली position पे आ चुके हैं, लेकिन अब ये तीन जो रह गए थे, the three that remained that have not been the first digit ever, these are one of these will occupy this position. So 3C1. Now when I go to the second box, now think, see, I've set a limitation कि पहली position, the first position will always have one of the disputed, one of these three digits, right? So if one of these, if I am hoping you're getting to what I'm getting at. See, if one of these will already be there, so out of these four, I won't have four options to select from. Instead, I will have three options to select from. Why? Because one of these will always be placed as the first letter, as the first digit. So out of these four, only one of them will be used here, and out of my four options, instead, I'm gonna have three options to choose from, and one of them can occupy this position. I hope that made sense and it was clear. And you can use your own, just use your brain power and tell yourself what I meant. And I think I'm pretty clear, and you can make sense out of it. Because kabhi kabhar you have to push yourself to reach these bounds, right? Now, two letters have been used, and seven remain. Out of the seven, two, any two can take these positions, move about to give a new number. And your conditions satisfy, you have dealt with all your disputes, and you are good. And by the way, there is a plus sign here. Why? Because these are two different cases. See, if a number is not complete, you multiply. Not complete, multiply. Now, if I'm making a different case, I am adding. That's why I say consecutively add. And if it's a completely different case, you add, right? Consecutively, you multiply. And if it's completely different, you add. If you're doing it all over again, you add. Many different ways to say the same flipping thing, right? And that, my friends, is permutation. Easy does it. Now, a word of advice, the same advice I've been on since always, is forget about me and do these questions on your own and get on with the past papers. Watch the techniques video. There's one or two more videos left. Perfect this concept and get it over with.